name is Miss Connolly. Give the same spiel at the beginning of each video now. I started making videos for my 5th graders to help them review while we're stuck at home, and decided that I wanted to make the videos public. I want to help as many students as possible. So please like, subscribe, and share. Let's get as many students learning math, keeping up with their math skills during this crazy time. If you have a topic you want me to cover, connollymathathome@gmail.com. So I just made a video about adding with decimals, and I talked about how important it was to watch the videos about adding with whole numbers first so that it could help you understand the strategies with decimals. And so I'm going to say the same thing about subtraction. Please watch the videos about subtracting with whole numbers through the grades, so that it helps you understand the strategies that we're using with decimals. So what I'm really hoping for people to see is that strategies that we use for whole numbers, for adding and subtracting decimals, can be used, for adding and subtracting whole numbers can be used for adding and subtracting decimals. There's a relationship, and it's important that we learn all the strategies for adding and subtracting so that when we get to 5th grade and we're adding and subtracting decimals, we feel confident with a bunch of strategies, not just the standard algorithm, even though I will go over that. So let's talk about subtraction. So up here, there's 9 3/10 minus 7 84/100. If you are trying to remember some stuff about decimals, I put a little place value chart for you down here. I do like showing all of these things with representations. However, it was really difficult to fit this on the little tiny board. So sorry there's no representations. I'll be working on another way to show you decimals with representations soon. So let's get started. So I go over this with each subtraction video, that when we are subtracting, we don't want to use this one strategy we use when we're adding. When we're adding, you can break apart both numbers by place value, but that doesn't work when we're subtracting, and I'll show you why. If you wanted to break this apart by the ones place, we would do 9 minus 7, but then you get to the tens place, and we're the tens place, we're subtracting 3/10 minus 8/10, and that's not going to work out for us right now. So we are not breaking both numbers apart. We are going to keep one number whole. You're always going to keep this number whole, the first one, and we're going to subtract from there. So what I am going to show you is keeping one number whole and subtracting this one by place value, and then we'll think about some other ways we can show subtraction. So 9 3/10, I'll show you on a number line. I'll show it with equations. Anything you want me to show you with subtraction of decimals, I can do. So 9 3/10. We're always going to start down here and subtract back to show we're taking away. So we're going to be going backwards. So I have 9 3/10. I'm going to keep that number whole. And first, I'm going to subtract by place value. So I am going to subtract 7 wholes away from 9 3/10. So when we're thinking about subtracting 9 or 7 wholes, the tens place isn't going to change. I'm just doing 9 wholes minus 7 wholes, 9 in the ones place minus 7, and that's going to give me 2 3/10. Okay, so what did I just do? I did 9 3/10 minus 7 wholes, and I got 2 3/10. Next, we are going to work on subtracting the next place value, which is the tenths place. So when I look here, I have 8/10 in the tens place. Now this is where decimals get a little bit tricky. So I'm going to show you, if you're feeling a little uncomfortable subtracting 8/10 from 2 3/10, I'm going to show you the steps that you can take. Okay, so landmark numbers. When we're talking about whole numbers, we want to use those numbers that have the 0 in the ones place, like multiples of 10, multiples of 100. But when we're working with decimals, we love whole numbers. We want to jump to whole numbers. Those are really helpful. So if I wanted to get to a whole number here, I would take away just 3/10 first. That way, I get to the whole number 2. That makes it a little easier for me to think about. So I've taken away 7 3/10 so far. I need to take away 8/10 and then 400s, but I wanted to stick with the tens place now. So now I can subtract those 5/10. I'll put a 0 here to make that a little more clear what's going on. 0 2 minus 0 5/10 would get us to 1 5/10. So if you're not feeling comfortable or confident going straight from 2 3/10 minus 8/10, break it up into parts and get to those whole numbers because they're easy for us to work with. If you are comfortable, you can just do it all in one step. I always run out of space on this board. I'm sorry, it's very small. Okay? I'm going to figure out where to write all that. So far I've subtracted 7 8/10. I did it by place value, and now I just have 400ths to subtract. So this is where we have to bring in our knowledge about equivalent decimals. I know that 1 5/10 is the same amount. It's equivalent to 1 50 hundredths. When I get to doing a lesson with the representations, I will go over this, but if you are subtracting decimals, you probably already know this. So 1 5/10 is the same as 1 50 hundredths. I wrote an equivalent decimal here so that it was easy for me to keep track of subtracting 4 hundredths. So 50 hundredths minus 4 hundredths, I get to 1 46 hundredths. So my answer here is what I land on. Okay, I started at 9 3/10. You can see I subtracted 7 8/10, and then 7 84 hundredths. Okay, so steps that I took, I'm just going to move this guy over here. I did 9 3/10. I kept it whole. I subtracted 7 wholes. That got me to 2 3/10. From there, I subtracted the next place value, which was 8/10, and I landed at 1 5/10. And from there, I was able to subtract 4 hundredths, and that got me to 1 46 hundredths. So in this solution, this strategy, when we keep a number whole and subtract in parts, our answer is where we land. You can see the 9 3/10 here, you can see the 7 84 hundredths here, and you can see the difference between the two numbers here. Okay? Let's move on to some more strategies. So that one is keeping one number whole and subtracting in parts. Another way that we can think about any subtraction situation is we can think about this as 9 3/10 minus something gets us to 7 84 hundredths. Or another fun way to think about it, which I love thinking about things this way, is we can think about it as what is the distance between 7 84 hundredths to get to 9 3/10. So we can use addition to solve. We can use subtraction to solve, but there's a relationship between addition and subtraction, and it's something we want to explore, especially when working with decimals. Okay? I will go over the standard algorithm at the end in hopes to help you understand that. So stay tuned if you want to learn about that as well. So in this strategy, I'm going to put 9 3/10 here. I'm going to put 7 84 hundredths here. I want to, let me get rid of all this jazz. I want to find the difference, which is the distance between the two numbers. And we use this strategy with whole numbers too. So I have 7 84 hundredths and 9 3/10, and my goal is to find how far is it from 7 84 hundredths to 9 3/10. I can go this way, or I can go this way. No matter what, the distance between these two numbers is going to stay the same. So first, we'll think about subtracting back. Then we'll think about adding up. And again, both of them are going to get you the same distance between the numbers. Okay, so our answer is going to be in a different place. You see 9 3/10, 7 84 hundredths are here. Our answer is going to be what is the difference between the two numbers? It's going to be up here. All right, so let's start with subtracting back. When we're subtracting back, I love whole numbers. Did I say that already? Let's get to whole numbers because they help us so much. So what we're going to do is we're going to try to get to 9 wholes here. Most of us can recognize if I take away the 3/10, I'm going to be at 9 wholes. So I'm going to take away 3/10 to start. Now I'm at 9 wholes. And guess what? I can get here pretty easily now. Because I'm using whole numbers, I know I'm going to do a big jump of -1 and get to 8. I have to figure out is how far away is 8 from 7 and 84/100. Let me make this a little bit bigger for us. So 7 and 84/100. What we're going to be thinking about is the same thing we would think about with whole numbers. I know that there's a total of 100 hundredths in a whole. So I'm thinking, how many hundredths am I missing to get to the next whole? Well, I know 84 plus 6 is 90. I know 10 more gets me to 100. So I know that I am, oh, just kidding. I know that I'm 16 hundredths. Sorry, 310 should be a much bigger jump. But anyways, I know I'm 16 hundredths away from here. So, what is the total distance between these two numbers? I have subtracted 3 tenths, I've subtracted a whole, and I've subtracted 16 hundredths. Well, let's look at it in equations, and we're going to find the total up here. So I subtracted 3 tenths, I subtracted a whole, and I subtracted 16 hundredths. So how much, here's where your answer is in the strategy, up here or right here. When we combine those, how far away is 9 3/10 from 7 and 84/100? Well, I have 1 3/10 plus 16 hundredths. So I'm going to think about this as 1 30 hundredths because they're equivalent, plus 16 hundredths. I get 1 46 hundredths. Do you see the 1? 30 hundredths plus 16 hundredths, it's 1 46 hundredths away. Okay, so that's if you're finding the distance subtracting back. So I'm going to go 1 46 hundredths here. Now let's look at adding up, because addition is so much more fun than subtraction sometimes. It's another way to think about the distance between the two numbers. So, like I was just explaining, working with whole numbers is a lot more fun than working with decimals. So when we start at, sorry, that looks really bad. When we start at 7 and 84/100, our first goal is going to be to get to that landmark number. Or if you like working with wholes and you want to add one whole to start, you could do that as well. Either one is going to help you out. But I'm going to jump to a landmark number because I don't want to work with decimals as much as you don't want to work with decimals. All right, so my first jump, I'm thinking about 84 hundredths. What do I add to 84 to make 100 hundredths? So 84 hundredths plus what is 100 hundredths, because I'm trying to get to a whole number. We just talked about that. So we know it is 16 hundredths. So I'm adding 16 hundredths. What does the number line represent? 7 and 84 hundredths plus 16 hundredths gets me to the number 8. And a lot of you are thinking, I know how much I have to add to get to the next step. You don't even have to do it in parts. You can do the whole thing at once. So what I'm going to do is I'm going to show what we have to add to get from 8 wholes to 9 wholes and 3/10. I add a whole and 3/10, and we call it a day. What is our answer? Where is it in the strategy? It's the distance between 7 and 84/100 and 9 and 3/10. So again, we have 1 3/10, which is equivalent to 1 30/100. Stay tuned, I'm going to go over equivalencies in another video. 1 30/100 plus 16/100 gets us 1 46/100. So as you can see, the distance going this way and going this way was exactly the same. And so I say, I'm always going to say this, why not add up when you're trying to find the difference between two numbers? Addition feels so much easier. I talk about this in subtraction of mixed numbers, I talk about it in subtraction of whole numbers, and now I'm talking about it with the subtraction of decimals. Use this strategy, practice it, it's going to be helpful, especially when you're trying to do stuff in your head too, because you want to be a flexible math thinker. So, last strategy, and make sure you watch the video on the US standard algorithm for subtraction so you can understand what's going on. The last strategy I want to talk about is using the standard algorithm to subtract decimals. Now, I make a big point about this in each standard algorithm video. You need to line up by place value. So I'm going to show you what mistakes students make. Okay? So actually, one mistake that they make is, there's a couple mistakes now that I think about it. Students are used to lining up numbers a certain way, so we get this. We see some problems with this, I hope. First of all, the tens place is lined up with the hundreds place, the ones place is lined up with the hundreds place, and the ones place is lined up with nothing. It's confusing, okay? So what you need to understand about the US standard algorithm for subtraction is that we subtract the same place value. We have to subtract the same size pieces, so we line it up by place value, okay? Another thing that kids want to do is it looks funny like that, so they just go ahead and flip it around and try to subtract like that. Subtraction, order matters. This is not what we're doing. Okay, so that's another no. No, no, no. Whoop. Getting too excited over here. Woo! Anyways, what we want to do is we want to line up our place value. We're starting with 9 3/10. We need to subtract 7 wholes and 84 hundredths. Ones is lined up with ones, tenths is lined up with tenths, hundredths is lined up with hundredths, and I'm going to show you what to do. This isn't negotiable. You need to write the equivalent decimal. Okay, if you are in my class, don't even. You are writing the equivalent decimal every single time. Don't tell me you're doing it in your head. No. Because what ends up happening is kids do this. Not the same. Okay? So it is not negotiable. You are writing the equivalent decimal. So what I mean by that is 9 3/10 is the same as 9 30 hundredths. If you are using the standard algorithm for subtraction, you have to write the equivalent decimal so that your place values line up, and you need to recognize that you have 0 groups of hundredths and you're trying to subtract 4 hundredths. So you need to regroup from the tenths place, and you need to say, I'm going to take away 10 tenths. Just kidding. I'm going to take away 1 tenth. I'm going to give myself 10 hundredths because 1 tenth is the same as 10 hundredths. So you have to write that equivalent. It has to happen. Okay? I know it looks like you're just writing a 0, but I'm being very clear. You're writing the equivalent decimal so that you can use the standard algorithm to subtract. Now we have 10 hundredths minus 4 hundredths is 6 hundredths. Okay? 2 groups of 1 tenth minus 8 groups of 1 tenth. We need to regroup. So we're going to take a whole. This becomes 8 wholes, and I'm going to add 10 tenths over here. So now I have 12 tenths. 12 tenths minus 8 tenths gives us 4 tenths. 8 wholes minus 7 wholes gives us 1 whole. 1 46 hundredths. The correct way to use the standard algorithm when you're subtracting decimals. So, important things to remember. Do not break both numbers apart when you are subtracting decimals. That is not going to work. You can either keep one number whole, you can subtract back, you can find the difference between the two numbers like we did here. Use those landmark numbers, those whole numbers. It'll help you. You know how to get to them and know how to travel from them when you're adding and subtracting. My recommendation is always to add up, but do your thing. And then when you're doing the subtraction standard algorithm, you must write the equivalent decimal. You need the same, you need the digits lined up by place value. It's not going to work if you don't do it in subtraction standard algorithm. You must. Okay? If you are in my class, it's not do not try it. Okay? You're always writing the equivalent decimal if you're using the standard algorithm. That's my rule. All right? Anyways, if you have any questions, you know my email, and I hope you enjoyed. Bye.